Hello, students. In this video, this is hopefully just kind of a fun video for you. This is teaching you how you can play this game called KenKen. It's kind of like, for those of you who know Sudoku, Sudoku, it kind of like that game, but it's a little bit more fun in my opinion, and it's also a little bit more math related. Sudoku can actually be played with colors, numbers, or letters. It doesn't necessarily need to be numbers. But KenKen, on the other hand, has to be numbers because there's mathematical operations that are involved in completing the puzzle. And you'll see what I mean as we move to this game. Now, what I want to show you is that I'm using new technology. I have a new drawing pad that I think you might like a little better. Let me know if you like it better. I think it provides a little bit more color. And it might come in a little bit more clear. I have a few more tools at my disposal, so I'm going to see how this works today. So you might notice that difference. So let's move on over to this new sketch pad that I have. You can see it's a little different. I got some different tools on the side and over here on the side and some things up top. We'll maybe bring some of those into play as we go through this. Now this is KenKen. So there's a website called www.kenken.com that you can go to, and this will create KenKen games for you, infinite number of them. It's a really cool site, and that's where I actually got this one. Notice this is a copy of the same KenKen. I'm leaving one of them, I'll leave this one on the right blank, and I'll work on this one here in the middle as we go through. Now, let's talk about the 2 or 3 rules of KenKen. There's only a couple rules that you need to know to solve these, and then they become fun, and we can begin to do a lot of them. What I want to do is start with the first rule. And the first rule says if we have a 3, this is a 3x3 KenKen, right? We have 1, 2, 3 columns and 1, 2, 3 rows, and that's basically going to be true of all KenKens if they are squares. So the idea is you need to put on each row and each column, you'll need to put the number 1 to 3 if it's a 3x3 KenKen. There's KenKens can be bigger, and they might be 4x4 and 5x5. We'll look at one of those in a little bit, but let's start with this one because this helps us understand the principles of KenKen. Now, so that's the first thing. I have to put a 1, 2, and 3 on each row and a 1, 2, and 3 in each column. So in other words, I couldn't duplicate. If a 1 goes here and a 2 goes here, then a 3 would go here. But you couldn't have a 1, a 2, and a 2 because you need a 1, 2, and 3 on each row, and similarly on each column. So there'll be 3 1s in this puzzle, 3 2s, and 3 3s, but none of them will be on the same row or column with the same number. The second rule of KenKen is that you got to always be looking at these solid boxes like this, and the solid boxes will give you an operation that you need to complete. So inside this box, the numbers need to add up to 3. So if you think about it, what numbers could add up to 3 that are different numbers out of 1, 2, and 3? Well, for those of you who said a 1 and a 2, you would be right. A 1 and a 2 have to fit into these boxes and not a 3, because if you put a 3, say, in this box, then you couldn't put a 1 or 2 here because this would add up to too many. So we'll get rid of that 3. So we know a 1 and a 2 have to go in this box. We don't know what order, but we do know a 1 and a 2 go in this box. Okay, so we'll come back to that. That'll probably be our first thing we have to figure out. Now let's look down here. These numbers subtracted from each other have to be 1. So this could you put a 3 and a 1 here? The answer is no. You could not put a 3 and a 1 in this box down here because a 3 minus 1 would be 2. So what pairs of numbers could you fit here? Well, you could put a 3 and a 1, a 3 and a 2, or a 2 and a 1. So you don't know. You can't really start here. So let's look over here. 2 divided by, oh, this is interesting. So we need to have a 3, a 1, and a 2 on this row. So if we put the 2 numbers that are in these boxes, if you divide one by the other, have to equal 2. Well, 3 divided by 2 is not 2, and 3 divided by 1 is not 2. So a 3 couldn't go in this. So a 3 is going to have to probably go up here. Now this is an interesting box too. This is 3 boxes multiplied together have to equal 9. Well, we'll come back to this one, and well, let's talk about that. If 3 numbers multiplied together have to equal 9, could a 2 be in any of these boxes? Well, the answer is no, because if any number that would have a 2 in it would be an even number. You can't multiply any number by 2 and get an odd number. So it's kind of interesting. If you're kind of thinking ahead, you can know that 2's couldn't go inside here, and that might give away the whole puzzle. So anyway, let's start with that idea. Well, maybe let's start with that idea. We'll know that you can't fit a 2 inside any one of these boxes, but I need a 2 on this row. So I know that the 2 has got to go here. Again, because if a 2 was here or here, this would be an even number inside this box. And so now things are going to all kind of come together. Let's start. Let's say we could start there, but KenKens don't always have to start in the same place. Here, remember, I decided that I couldn't have a 3 inside this box. So we could have started over here and said, remember, because a 3 divided by a 2 or 3 divided by 1 wouldn't work here. So a 3 would have to go here. And now I know that I can't put a 2 here because a 3 times a 2 would be a 6. And then I couldn't multiply that by anything to get a 9. So this has to be a 1. And this has to be a 2 because this has to be a 2 because along this first row, I need to have a 3, a 1, and a 2. So now I can fill in all the rest of the boxes pretty easily. If this is a 3 plus, I need a 2 plus a 1 would give me my 3 here. On this column, I would need a 3 here to have the column rule of having each number represented once. Then coming this way, I need a 1 or a 2? Well, I can't have a 1 here because a 3 minus a 1 would be 2. So this has to be a 2. So this has got to be a 1 because I have to have a 1 on every row. On every column, I need to have a 2. So this, and that's good because this 2 divided by is 2 divided by 1. And then that leaves a 3 here, and that works. 3 times 1 times 3 is 3. So I have solved this KenKen. I could give myself, let's see. Do we have some cool clip art? We can give ourselves a animal. Well, I haven't loaded up any clip art here, but I could give myself a nice star. How about a bigger star? Cut out sides. 4-sided star. Let's select that star and let's make it big. Whoop, we can twist it around. I don't know. There we go. Big star. Good job. Okay. So the next thing that we're going to do is we're going to try a different puzzle, and let's go. Let me show you this website. It's pretty cool. Come back to my Google Hangouts. Just a sec. Bear with me for a second. I'll come back to presentation mode, and then I'll cut over here to this screen here and go to my KenKen. Hold on a second. Whoops. There we go. Sorry. There we go. Let's go back here. So we could go to www.kenken.com, and then we get this page here, and we can just simply say, go select on a 3x3 puzzle, and we're going to pull up another 3x3 puzzle. I'm going to put that one. Oh, we already did that one. We just did that one. Let's do another one. Yeah, this one actually has a different, we'll have a different little thing on it that we're going to need to learn about. We're going to copy this guy. I'm going to put it over. Make a new, just a sec, bear with me. Here we go. Got to set this up. Pardon my, where am I? There we go. All right. Sorry about that. That was a little bit, there we go. We're back. Okay, we're going to do one more KenKen puzzle, and then I'll let you off in doing your own. But we'll just run through this one a little bit more quickly. And what I'm going to do is I'll make a copy of this and put it over here, and then we'll think through this one. I'll leave the original over here on the right so you can see what it looked like before we started. So there's a new thing here, and it's called this box right here, and it's basically, if there's a box with a number, that's just a freebie. This says the number 3 goes in this box. There's no operations, so I'm just going to put a 3 right here. So I know then there's a 2 and a 1 that go in this box, and that makes sense because I have to have a 1 and a 2 in this box because there's a 3 here. So let's look at these other operations. Well, there's 2 ways I can go with this one. I know that if this is a 6 times, I need to have it in this box. I need to have a 1, a 2, and a 3. What 2 numbers multiply together to give us 6? Well, that's a 3 and a 2. Can't be a 1 because a 1 and a 3 and a 1 and a 2 won't work. So if we have a 3 and a 2, I can't put my 3. I can't put my 3 here because then I'd break that rule of having 2 3s in the same column. So I know my 3 has to go here, and my 2 has to go here. And now I can really start to fill the rest of this thing out if I want. But let's look at this box over here and see what's, rather than go with the row and column rule, let's just see if we can use our noodle this one through. Well, we know that this is a 2 minus. And if this is 2 minus, that means that I can't have a 3 and a 2 because 3 minus 2 is 1. And then a 2 minus 1 is 1. So this has to be a 3 and a 1 because that's the only thing that will give me a 2 if I subtract them. So I could go 3, 1. Oh, but I think you guys see why that doesn't work because I can't have 2 3s here. So I have to put a 1 here and a 3 here. Now we can just fill out the rest of this thing using our knowledge of rows and columns. So we know that in this column, I'm missing a what? A 2. In this row, I'm missing a 1. In this column, I'm missing a 2. And then in this row or this column, I'm missing a 1. And so there's your answer here. Okay, so that's how you do KenKens. Let me just challenge you really quickly and show you that KenKens can get a little bit bigger. And I'm going to drop another one down for you. And they can also get a lot more fun when they get bigger, or at least I think so. So let's put this one down over here. And maybe I'll just run through this one kind of quickly. Let's just run through this one here kind of quickly, and don't worry about. You can slow it down and watch it later, but I'm going to kind of solve it so you see some of the other principles that you hit when you get bigger. Okay, well, let's watch this one. A 3 and a 1. I know that this has got to be a 4 and a 1, so I'm going to put a 4 and a 1. I'm just going to make a notation to myself that this is a 1 or a 4, and this is a 1 or a 4. So I know that this here is a 2 or a 3, and a 2 or a 3. A 2 or a 3 go here, and a 2 or a 3 go here. Well, I know a 3 cannot go here. A 3, I can't put a 3 here because there's nothing I can divide 3 by to get a 2 that's between a 1 and a 4, right? This puzzle goes for 1 to 4 in every column, so this can't be a 3. So the 3 has to go here. And a 1 has to go, no, well, I already used a 1, so this has to be a 2. Okay, now I'm off and running. Now I know, let's see, let's look here. This has to be, these two numbers, if I have a 3 here, the other number that I have to multiply by is these two numbers have to multiply to be a 4. Well, that can be a 4 and a 1 or a 2 and a 2. But I can't put a 2 and a 2 here because then I break my rule about having 2 2s on the same row. So I have to go 1 and a 4 here or a 1 and a 4 here. I'll just put my notes down there. And those, if that's a 1 and a 4 and that's a 1 and a 4 or a 4, then the 2 has to go here. Okay, seeing how this works? So we're going to keep going and we're going to say, well, this has to be, well, if this is a 2, notice this has to be either a 4 or a 1, because I could say 4 divided by 2 is 2, or 2 divided by 1 is 2, but it cannot be a 3. Can't be a 3 because 3 divided by 2 is wrong. So a 3 has to be down here. So I have to have a 3. So if I have a 3 in this box, think about what else could go there. Could I have a 4 with a 3? No, I can't have a 4 with a 3. I can't have a 2 with a 3. So the only other thing I can have with the 3 is a 1. So I'm going to put a 1 in a 3 and a 1 in a 3 here. So the 1 has to go here or here, and the 3 has to go here or here. So I can't have a 1 here. So this, whoops, has to be a 4. That has to be a 4. And if that's a 4, then this can't be a 4 here. The 2 divided by, this has to be a 1, and then this has to be a 3 by the row rule. And if this is a 1, then this can't be a 1. This has to be a 4. And then this can be a 1. And so I'm starting to fill this thing out. And let's see. If this is a 1 or a 3, and this is a 1 and a 4, I can't do anything over here right now. So let's look over here. 2 divided by. Well, I know that a 1 has to be here and or here. So if the 1 goes here, then I have a 4 goes here and the 1 goes here. So I know that one of these is a 1. The 1 has to go here and here or here and here. So I filled out my 1. And in fact, I can't put a 1 anywhere on this row anyway because there's a 1 here and a 1 here. So this down here has to be a 2 and a 4. I have to have a 2 and a 4 here to make my 2 divided by. There's only 2 ways to do it, with a 2 and a 1 or a 2 and a 4. But the 4 can't be here, so the 4 has to be here. This has to be a 2. There's my 2 divided by 4. And if there's a 4 here, this can't be 4. So this has to be a 1. And if that's a 1, then this has to be a 3. And if that's a 3, this has to be our 1. And if that's our 1, this has to be our 4. And then this has to be a 3 because of the column rule. And this has to be a 2. And we have 3 plus 2 plus 3 is 8. So everything works out, and we've finished our KenKen. I know that might have been, this is a little much. You have to think through these, but that's kind of how you solve the more advanced ones. And let's return now to our Hangout. And what I want you to do is I want you to just try some of these KenKens. I have a few 3x3 and 4x4 printouts that you can do here in class. If you're at home or this is not this is later in the year, you're just excited to do KenKen, go to KenKen.com. They're a lot of fun. They also enforce your math facts for you at the same time, and I just enjoy them. And we'll probably be doing a few more during the year. Hope that was helpful. Hope that's fun. Be seeing you in class.